When people imagine aliens, we usually think of grey humanoids with big black eyes, or maybe something straight out of science fiction, tentacles, glowing skin, or advanced intelligence beyond comprehension. But if we strip away imagination and stick only to science, one question becomes far more interesting. What would an alien from a real rocky planet actually be like? Not what we want them to look like, but what physics, chemistry, and evolution would realistically allow. Today, we're going to explore exactly that, using everything we currently know about life on Earth, exoplanets, and the conditions needed for biology to exist. And by the end, you might realize something unsettling. If alien life exists, it probably won't look anything like what we would expect. Right now, Earth is the only confirmed example of life in the universe. That means every prediction we make about aliens starts with one dataset: biology on this planet. Life here is built on carbon chemistry, liquid water, DNA-based evolution, and energy extraction from environments. So when scientists look for alien life, they don't start with imagination, they start with constraints. Physics first, biology second. To imagine alien life, we first need to ask, where could it actually survive? Astronomers now know that there are billions of planets in just our galaxy alone. Many of them are exoplanets, planets outside our solar system. Some are rocky, like Earth, and some orbit in the habitable zone, where liquid water could exist. That's key. Not because water is magical, but because it's an excellent solvent for chemistry. It allows molecules to move, collide, and form complex structures. But even within the habitable zone, conditions vary wildly. Some planets might have thick atmospheres like Venus, others might be frozen like Mars, some could have stronger gravity or weaker magnetic fields. So any alien life would already be shaped by extreme environmental pressure. On Earth, evolution is not random chaos. It follows a few major rules, and these rules would likely apply to alien life too. First, survival favors efficiency. Evolution doesn't create perfect organisms, it creates organisms that waste the least energy while surviving long enough to reproduce. You can actually see this on Earth everywhere. Birds evolved hollow bones for lighter flight. Deep sea creatures move slowly because food is scarce. Everything in nature is constantly balancing survival against energy cost. And that leads into the second rule. Energy use is everything. Every living thing needs energy to move, grow, hunt, think, and survive. Even human intelligence is extremely expensive biologically. Our brains use a massive amount of energy compared to the rest of our bodies. So intelligence only evolves if it's actually worth the cost. On another planet, evolution might favour something completely different. Maybe creatures become incredibly efficient instead of intelligent. Maybe life remains simple for billions of years because simplicity works. The third rule is that adaptation depends entirely on environment. Life changes based on the conditions around it. Desert animals conserve water, deep sea creatures handle pressure, cave animals sometimes lose their eyesight completely because vision becomes useless in darkness. So on alien planets, different environments could create life forms that seem bizarre to us, but make perfect sense for their own world. And finally, random mutation and natural selection drive complexity. Small random genetic changes happen constantly. Most do nothing, some are harmful, but occasionally one gives an organism an advantage. Over millions of years, those tiny advantages stack together and create incredibly complex life. That means alien life probably wouldn't look designed. It would look evolved, shaped slowly by survival, environment, and time. So if life exists elsewhere, evolution will still work the same way. That's important. It means aliens aren't designed, they're shaped. So instead of asking, what would aliens look like? Scientists ask, what body plan would be most efficient in that environment? Let's imagine a rocky planet slightly larger than Earth. Higher gravity means shorter, stronger organisms are favoured, tall creatures become structurally inefficient, and movement requires more energy. So instead of humanoid giants walking upright, you might get low-profile, ground-hugging organisms, wide, stable body structures, and possibly even multi-limbed crawler forms. Now imagine the opposite, a low-gravity planet. There, evolution could favour taller organisms, floating or gliding motion, and more fragile but expansive structures. So even before thinking about intelligence, gravity alone completely reshapes biology. On Earth, we rely heavily on vision, but that's not guaranteed elsewhere. On a planet with thick fog-like atmosphere, vision becomes useless. Dense oceans, sound and pressure become more important. Weak light from a red dwarf star, infrared sensing might dominate, so alien senses could be radically different. Echolocation like bats or dolphins, electromagnetic field detection like some fish, chemical smell mapping over long distances could even be possible. An alien might not see you at all, but it might feel your presence through environmental changes. One of the biggest assumptions we make is that intelligence leads to a humanoid shape, but evolution doesn't care about symmetry or aesthetics, only function. On Earth, intelligence evolved multiple times. Primates, dolphins, corvids like crows and ravens, and even octopuses. Notice something important. None of them look even remotely similar. In fact, octopuses are especially interesting because their intelligence involved a completely different body structure. Distributed brains, flexible limbs, and problem-solving ability without a central human-like brain. So alien intelligence could be distributed across a colony or organism, it could be hive-based like insects but far more advanced, or even planet scale, a networked biosphere acting as a single system. Carbon is the best known building block for life because it forms stable, complex chains, but other possibilities exist, like silicon-based chemistry, less flexible but still possible in theory, or alternative solvents like methane or ammonia in extreme environments. However, scientists still consider carbon-based life the most likely because it's extremely versatile, it works across a wide temperature range, and it's abundant in the universe. So even alien life might still be carbon-based, just not Earth-shaped. Now this is where things get interesting. Not all life has to be large or even visible. On Earth, most life is microscopic. Bacteria, archaea, microbial ecosystems under ice or rock. So statistically, if life exists elsewhere, it may also mostly be microscopic. That means the most common alien life in the universe might be invisible, simple, and widespread. Not spaceships or civilizations, but microbial ecosystems under alien oceans or buried beneath rock. Now here's a difficult question. If alien life is too different, would we even know it's alive? This is one of the major challenges in astrobiology and SETI research, the search for extraterrestrial intelligence. SETI Institute works on detecting signals that might indicate intelligent civilizations, but even that assumes intelligence uses detectable communication. Life elsewhere might not emit radio stations, build technology, or even behave in ways we classify as life. It could exist in forms we mistake for geology or chemistry. So after all of this, what's the most scientifically realistic alien? Not a humanoid, not a monster, not something designed for storytelling. The most realistic alien is probably simple or microbial, adapted perfectly to extreme conditions, chemically familiar but structurally unfamiliar, driven entirely by evolution, not intelligence or intention. And if complex aliens do exist, they are likely so shaped by their environment that they would feel less like characters and more like entirely separate branches of biology. When we imagine aliens, we usually imagine them as variations of ourselves, but science suggests something very different. If life exists elsewhere in the universe, it won't be designed around human expectations, it'll be designed around physics, chemistry, and survival over billions of years. And that means the universe may be full of life, but almost none of it would look like anything we could easily recognize. Which leads to a final thought. The real mystery isn't just whether aliens exist, it's whether we're even capable of recognizing them when we find them. Thank you for watching this video. I hope you enjoyed exploring the science behind potential alien life. Let me know what you think a real alien could possibly look like down in the comments. Make sure you hit the subscribe button, and if you have anything you would like to explore with me in a future video, I will do my best to make that happen. Stay curious.